Hi, pre-calc students. We're up to complex fractions day 2, and I will tell you that this note sheet right here is included in your packet. So if you want to take out the unit 1 and 2 packet and start working through some of these questions, go ahead and do that. So we talked about complex fractions yesterday, and what we saw is that we really have to identify the LCD before we can proceed with simplifying the complex fractions. So what we'll see for this first example here is that maybe these are starting to look a little bit more complex than the other day. I mean, I guess that's sort of a bad pun in this case, because complex just means fractions within fractions. But the ones that we'll see in today's notes are, I will say, a little bit more complicated than what we saw in the prior lesson. So first thing you have to do is when you're looking at these denominators and trying to identify the LCD, I'll put that little 1/1 in case you like the look of that. But you have to identify the LCD by considering, do any of these denominators factor? Okay, so I'm going to change p squared minus 9 into p plus 3 times p minus 3. And rewriting it in that format helps me to now clearly identify that when I look at this denominator and this denominator and this denominator here, that the LCD is really the product of p plus 3 times p minus 3. So what we're going to have to do is, if we've established that as the LCD, you have to multiply the top by the LCD and then the entire bottom by that LCD. So sorry if this is getting a little bit messy, but we're going to multiply the top by p plus 3, p minus 3, and then do the same thing in the denominator. And let's write down what that result looks like. So on the top, here the p plus 3s would cancel, right, for the first fraction. And when those p plus 3s cancel, we're going to be left with p times p minus 3. And then there's a plus sign there. Plus, here, these two factors cancel in total with these factors that I'm multiplying by up here. So you're just left with plus p. And then this is all over in the denominator. Here, the p minus 3s cancel. So we're left with 1 times p plus 3, which is just p plus 3, plus 1 times that LCD is just the LCD all over again, p plus 3 and p minus 3. So stop for a second. Make sure that that makes sense to you as far as what we're left with after multiplying through by the LCD. Because now we know that our job's not done yet. We have to ask ourselves, can we factor and simplify this any further? And in order to do that, in this instance, there's 2 routes you can go. One route you can go is saying, all right, let me distribute that p in on the bottom, multiply these out, and then add the p plus 3 to it, and combine like terms. And that would be fine. Once you're done with that, you still have to think, can I factor it? But in its current state, it actually already is factorable. And this typically is not as obvious to students, but I hope that this will make sense. In the numerator, we have this term separated with the plus sign from the second term. What do those 2 terms have in common? They have a p in common. So if I take out a p, I'm left with p minus 3 from the first quantity, plus from the second quantity. If I take p out of p, I'm left with a 1. Because remember, I have to be able to distribute that p back in and get what I had here a second ago. So don't forget about plus 1. In the denominator, both of these terms have p plus 3 in common, right? Here's one term. Here's the second term. Since they both have p plus 3 in common, I can factor that out as a GCF. And I'm left with 1, right? Take p plus 3 out of p plus 3. And when I take p plus 3 from there, it's 1 plus the quantity p minus 3. Now, I don't need really parentheses around that p minus 3 because it's 1 plus that quantity. If it was 1 minus the p minus 3, that parentheses would have been important because I would have needed to distribute it in. Okay. So it's a little bit of a different look than what we're used to seeing, I think, when we take out GCFs, but I think that this will help as a strategy for examples later on. All right, so clean up what's inside the parentheses there. Inside the parentheses, negative 3 plus 1 is going to be p minus 2. Okay, in the denominator, 1 minus that 3 is going to also give you a p minus 2. So therefore, cancel those p minus 2 factors on the top and bottom, and the final answer is p all over p plus 3. Now, like I said, if you had gone here and distributed the p in and multiplied this out and combined like terms, you're eventually going to get to that same exact answer. But there are definitely benefits to looking for that GCF on the top and bottom. And we'll see examples why later on. We definitely want to look for a GCF when simplifying at this stage in the process. Now, you've probably noticed as I've been working through number 1 that number 2 says try it. So I will not do number 2 in the notes with you today, but I would expect that if I checked your notes in class when I see you tomorrow, that number 2 would be attempted. So please make sure at this point you hit pause, try number 2, and the next one that I'm going to do with you is number 3. Taking a look at number 3, first thing we have to do is identify the LCD. So if you like those 2 over 1s, go for it. And the thing is that these two quantities, these binomials x minus y and the 2x plus y, they have nothing in common. So in other words, they can't be factored. There's no special GCF you can take out or factoring technique that would make these look more similar to one another. Whereas if I look at number 1, yeah, I mean, factoring p squared minus 9, these two factors were both in other fractions. So that made my LCD much less complicated. In this scenario for number 3, the only thing we can do to simplify the complex fraction is to find the LCD to be the product x minus y times 2x plus y. Okay, now that I've defined my LCD, we're going to multiply the top by that LCD and then multiply the denominator by the LCD. Okay, so on the top, let's see what happens. The 2 is going to get multiplied by x minus y and 2x plus y. And in the second term, the x minus y's will cancel. So it's going to be minus 3x times 2x plus y, right? X minus y is canceled here, so the 3x gets multiplied by 2x plus y. All right, in the denominator, we get 2 times x minus y times 2x plus y minus the 3x. Here, the 2x plus y's cancel out this time. And you're left with 3x times x minus y. So stop there. Make sure that that step made sense as far as multiplying by the LCD to get rid of the complex fraction. Now, at this stage in the game, could I multiply things together up here and distribute a negative 3x? And do the same thing in the denominator, multiply them together and distribute the negative 3x? Sure. But what I think might make your life easier, and I want you to try making more attempts at, is taking out a GCF. What is the GCF in the numerator? Well, here's one whole term. Here's another whole term. They both share the factor 2x plus y. So take that out as a GCF, 2x plus y. And then write down what the leftovers are. It's going to be from the first term, if I take out 2x plus y, 2 times x minus y. Minus, when I take 2x plus y from here, just 3x. Okay. Then in the bottom, similarly, here's one whole term minus this whole term. They both share x minus y in common. So when you take that out, you're left with 2 times 2x plus y minus that 3x. Okay. So now what happens is when you take out the GCFs, you want to look at the leftovers on the top and bottom in these parentheses and see if we can clean that up and possibly do some more factor canceling there. Okay. I'm going to do a little bit of this in my head. Hopefully it's okay. 2 times x is 2x, right? 2x minus 3x is negative x. 2 times negative y is minus 2y. So when I distribute the 2 and combine like terms, you'll be left with this. In the denominator, leave the x minus y on the outside, distribute this 2 in. 2 times 2x is 4x. 4x minus 3x is 1x. When I distribute the 2 to the y, it becomes plus 2y. Now, these factors look very, very similar to one another. However, one of them is the negated form of the other. So all we have to do is we are allowed to cancel those, but just make sure you know that you're left with a -1 factor. If you were to factor out -1 from this binomial, you would be left with x plus 2y. So what am I going to do with that -1 that gets factored out? I'm actually just going to leave it in front of the factor in the numerator. It's completely up to you if you distribute that in, but it's sufficient, in my opinion, just to leave it out in front with those parentheses and actually leave this as your final answer then. So it's the negated quantity of 2x plus y on top divided by x minus y in the denominator. All right, so I actually will say number 3 looks pretty good for now. Go ahead and try number 4. I'd expect to see that filled out in your notes next time I see you. All right, number 5. For number 5, we want to do the same thing. We've got a lot of denominators here. Look at all these denominators and decide what the LCD is. Okay. There's no way to factor those denominators, so it's not like I'm going to be able to break those down and find something in common. So I'm hoping in number 5, you're jumping right to saying that the LCD is x minus 3 times x plus 7. So when you multiply through by that LCD, x minus 3 times x plus 7, in the first instance, the x minus 3's would cancel, and you'd be left with x times x plus 2 times x plus 7. Minus, here the x minus 3's also cancel, and you get 15 times x plus 7. So that's the numerator. Denominator, first and foremost, x plus 7's cancel to get -15 times x minus 3. Plus, for my second quantity here, the x plus 7's cancel again to get x times 2x plus 7 times x minus 3. Okay. That idea of taking now a GCF out on the top and bottom is critical in this example. Because if we don't do that, if I multiply all of this together, it's going to become an x cubed polynomial, which then in the end will be much tougher to simplify if it can be. So look at this whole thing as one term minus this whole thing as another term. And what do they both have in common? X plus 7. So when I take out x plus 7, that leaves me with x times x plus 2. And from this term, minus the 15. Do the same thing in the denominator. Here's one term, here's another term. They both have x minus 3 in common. So what does that leave me with? -15 plus x times 2x plus 7. Okay. So once you take out those GCFs, now what we have to do, I call this cleaning up the leftovers. Clean up what's on the inside of those parentheses and see what you have. So we get x plus 7 times, here you're going to get x squared plus 2x with the -15, right? Distribute that x. In the denominator, we have x minus 3 times, so I'll distribute that x in, 2x squared plus 7x, and then I'm going to just write the -15 at the end. Okay, I'm running out of space here, so I'm going to bring up my work up over here for a second here. Each of these trinomials, you want to see, can you factor them? So we've got x plus 7, and then x squared plus 2x minus 15, that factors to x plus 5 times x minus 3. In the denominator, we've got x minus 3 down there. 2x squared plus 7x minus 15. A little bit of a tougher factoring, right, with that lead coefficient of 2. But if you do reverse box method or guess and check or slip, divide, slide, it's up to you. But to make that positive 7x in the middle, I believe it would have to be an x plus 5 here. And then 2x minus 3. Let's double check that, right? So we get 10x minus 3x for 7x in the middle. Yeah, that looks good. And now we get to do the fun part, which is cancel. The x minus 3's cancel. The x plus 5's cancel. And the final answer is x plus 7 over 2x minus 3. Okay, so if you have any questions about number 5, that was probably one of the more complicated ones that we'll see as we go through the process here. You'll notice number 6 was crossed off. You can skip number 6, and you can even skip number 7. But the last thing that I'll ask you to do is try number 8. So in this lesson, you saw a few examples completed, 1, 3, and 5. And the ones that you're going to try on your own are 2, 4, and 8. And then if you have questions about those, we will go over them the next time that I see you in class. But make sure you have the rest of those filled in. Have a good one, guys.